G'day guys, today I'm building something that I think will be incredibly useful for when you're solo live streaming. Whether you're in control of a drone or operating a ground camera, taking your hands off your gear to switch can quickly stuff up your shot and make you look like a numpty. No guarantees this is going to stop me looking like a numpty, but best efforts, all that sort of stuff. So what's the solution? This is a hands-free dual foot switch controller for the ATEM Mini Pro. It'll work with the ATEM Mini, it'll work with the Pro ISO, of course, all that sort of stuff. This will let me switch the camera, triggering transitions and controlling the ATEM without ever taking my hands off what I'm doing, which is normally on the controller for a drone. So I'm going to walk you through the entire build, how I've wired the foot switches, how I've set up the Python scripts in Raspberry Pi, how I plug them all into the GPIO pins, all that kind of good stuff. You'll see it all in a minute. And showing you the final result, of course, so let's get into it. Let's run through everything that we're using in the build. Raspberry Pi, the trusty ATEM Mini Pro, and of course a power adapter and USB-C cables, Ethernet cable, all that sort of stuff. Two momentary foot switches, which look very much like sewing machine pedals, but they're not. These ones are on or off. So basically you press them down, it completes a circuit. The DuPont, don't care how you pronounce it, but they're these little plug-in leads that came with my Raspberry Pi and extended pack that I have, etc. They're cheapest chips, you can get them basically anywhere. They just plug into the GPIOs, and I've left one of those bare so I could show you how that connects there too. And this is the cheapest and nastiest case I could get off Amazon. Basically, I know this isn't going to last, right? The idea is to mount the pedals on top and have a stomp box that way. I'm just using this as like a bit of a beta build. I want to test it, make sure it all works, make sure it's easy to access, and I don't want to drill into like a $60 box and then figure out that I need to configure it some other way. So yeah, cheap box to start with, but grab yourself a good box if you're confident. Quick side note, you may be asking why I'm using a load balanced router instead of a managed switch. Simple answer, I don't have a spare managed switch at the moment. I can't be bothered tearing it out of the CCTV. So I'm just using this, basically a spare little piece of kit that I've been lent by a mate. Shout out to Jordan. All right, and I think that's about all you need. It's a simple and hopefully reliable setup. I'll report back also in a few months with how she's actually gone in the field on live jobs, but for now, let's start with the build. Okay, so each of these foot switches are just a simple momentary contact. It closes a circuit when you press it, so it sends that signal where it closes the circuit between the ground and a GPIO pin, and then triggers in the script to send a command to the ATEM Mini, do this. Okay, single click, do this, long press, do that. So we've got two switches for this one. What we're going to be able to do is control either a hard cut with a quick single press, which is the one I'd probably use the most. And then I can do like basically the auto transition depending on the setting if I long press. So that will be the left switch. On the right switch, we're going to be able to move throughout the inputs. So from 1 to 2 to 3 to 4. And yeah, if I double press it, it'll go back. So from 4 to 3 to 2 to 1. So I can not have to do sort of going around the horn to get from 2 to 1. And that's the config. That's basically the script. Yeah, each of these foot switches, like I said before, is just a simple momentary contact. So it closes the circuit when you press it. Magic. Mate. So I've wired this in the simplest possible way I could. It's essentially going to 3 pins. 2 pins will be, let's just call them a positive. They're basically, they're the unique signal switch. So when a circuit closes on that pin, it will trigger through the script to send a command to the ATEM and do a thing. The third will be a ground. So we've got 2 trigger points and a common ground. So you can use, I think there are 3 grounds through the GPIOs on the Raspberry Pi. You could use your individual grounds, but why bother? May as well just pair it all up. Keep it simple. Less points to come out, I suppose. But if that ground comes out, everything goes to shit. So yeah, let's kick on. What we will go through now is the wiring. I'm going to try my best not to stuff it up. I already stuffed something up, and no, I'm not doing outtakes. So I'm glad I bought 20 of these little clip babies off Amazon. I think they're about $7. But usually, like I sort of alluded to at the start, how they work is when the wire's in there and you press the back hinge down, it pushes the wire through a couple of sharp bits, cuts through the insulation and makes a connection. Don't usually like using those sort of things. I'd prefer to strip and solder and all that sort of stuff, but we're not using any real form of voltage here at all. It's purely a signal path that we're closing, so you know, this will work. This will work a treat, and I won't have to muck around with inhaling lead and getting dumber and all that sort of stuff. So let me show you how these things work. But essentially, we're going to need to strip. Ha! How cute are these scissors, by the way? Look, a samurai sword thing that a friend got me from Japan. I use them all the time. We've got the common wire, all right? So that's obviously got to go to, that's got to go to one of each. The pedals I'm referring to there, by the way. And then we've got a double. So these will be our signal wires. So essentially, it doesn't matter what polarity you have them, because I know you're getting sick of me saying it, but it's just a signal. Look, like you can see on the Amazon snapshot, screenshot thing that I gave you, basically feed the wires in, and they kind of hit a point where they click. So they do go in a fair way, but you do have to sort of hinge this up a little bit further than you feel comfortable. And then once you're all the way in, use your little mousse glaze to cinch it down, and it clips in, and what you've done there is just push those insulated wires past little cutty bits, and we do it again. Do it from this side. Okay, so now we're at the point where we actually plug stuff in. My eyesight is bloody awful, so this is going to be fun. We're going to go 3 pins on the outside for the ground. Just 1, 2, and thanks for knocking that, idiot. There we go, 3. And then we're going to come down 2 pins on the inside and 3 pins on the inside. So I might just hit the 3rd pin first, because we've already got a guide there from the ground. Hippie, hippie. And then the 2nd pin, which I'm completely obscuring in this shot, you're welcome. And that's her. Okay, now let's, I suppose, reposition everything and get the ATEM connected. See if it works. Okay, now this is a complete dog's breakfast, but for the purposes of the demonstration, let's just see if it all plugged in is going to work. One thing I found out after like far out hours of going, what the hell is going on, is that the ATEM needed to be switched into the LAN port, because this is a balanced router. The router treats WAN and LAN quite differently. However, the Pi can be sort of plugged into a WAN LAN, but neither could be plugged in to the WAN port. So it all had to run on 4 and 5, which doesn't sit well in my brain, but look, at this point I don't care. That took me a very long time to troubleshoot. You network wizards would be like, you're a complete moron, well done. Anyway, there's that. Also, because the Pi is running on 192.168.0. network essentially, and my Wi-Fi is running on 192.168.168, whatever. That number's different, the O and the 8 at the 3rd point. There were some serious conflicts where the Pi was trying to pick up and run on the wireless and allocating the rest of the network that 0.8 in the subnet. So it all sounds like a lot, and maybe I got some of the words wrong, whatever. But yeah, my tip before you go and build all of this is, if you are going to be running on a Wi-Fi network, get your subnets exactly the same, if that's the right way to call it. Make sure that your Wi-Fi network is using the same spread of IPs, I suppose, based on all of the prefixes before you get to that last number. Don't know if I explained that very well. Sorry if it's confusing and makes no bloody sense. Anyway, that was also a nightmare. That took me hours, but hopefully knowing what to look out for will save you that drama. It really was drama. So yeah, let's see if it actually works. Hey, let's press some buttons. Press this one. Oh, okay, so we've got them round around the wrong way. That's not what I want. What I want is my left pedal. I'm going to mark these, by the way, and probably put some paint on them. Is I want this to be my cut. And, oh, so good. Oh my God. How good's that? And this to step through my program. Noting though, I didn't find a workaround in the Python to actually skip past whatever is live at the moment. So I'm going to need to remember that. It's a little bit finicky. If anyone's got any suggestions for that, pop it down in the comments, all that kind of stuff. I hate when people say that. But you've got to say it, right? It's YouTube. Yeah, like, comment, subscribe, all that sort of stuff. Anyway, so yeah, it looks like it's working. The only thing, okay, so hold that, let go. Oh, nice transition there. The director will hate that, you handling transitions if you are working on a multi-feed live stream. I will create a Google Doc, link it in there, and have all of the instructions, basically a full guide how to put all of this together, what scripts to use, tips and tricks along the way, all that sort of stuff. I hope you find that helpful. The next step, essentially, I'm just going to tidy all of this up, get it into the box, and once that's done, I've got a stomp box, and I can stop stuffing up the last few frames of my shot while I switch it over to the next camera. So yeah, and here she is. End of the build. Drill some holes in the tops and the sides. We've put the Pi and the router inside, left the power outside for this build. When I get a decent case, I'm going to be mounting everything inside, and as I said, hopefully be running everything off 5 volt. It'd be super handy. Not bad, huh? And that, ladies and germs, is the complete build. So Raspberry Pi, 2 foot switches, a bit of Python, some cables, and oh man, I got to tell you, it's probably about 12 hours worth of mucking around because I'm not a Python coder, but I learned a lot. It's such a flexible language. And now an ATEM controller that's fit for live production. Thanks to Shane Hutt for suggesting I actually do this. It was a really good suggestion, even though I think maybe he was joking. But I would also love to be able to expand this with tally lights. I did have a look at that, but I think maybe my little LED board was a bit stuffed from factory, so I couldn't get it working properly. It was all flickery and weird, but love tally lights. They're my favorite thing in the world when I'm working on a live stream. But for my next little project, I'll be taking this setup to the next level by transforming this little Raspberry Pi I've got here into a high performance, ultra low latency SRT Ethernet video bridge. Since the ATEM Mini is essentially natively locked to RTMP, I know there's a firmware update that does SRT, but I think it only goes to YouTube, and I can't figure that out anyway. I can actually use the Pi and an open source media proxy called Media MTX, Mike Tango X-Ray, to capture that local network feed and instantly repackage it into SRT, which is crazy because you would think that it's like a full re-encode, but it's not. It's just, I think, some data wrappers and that sort of thing. So it barely touches the CPU, meaning even this like 5, 6, 7-year-old tiny little SoC board can manage the pedals, run like a graphical UI as well. Oh, that's what I meant to mention. I didn't install the terminal only Pi because I wanted to be able to use Raspberry Pi Connect. So I can actually remote in as long as I'm on the same network and manage it on a laptop rather than having to plug in keyboards or use that little small keyboard I got and stuff. Anyway, so I've actually used the full, I think 64-bit Raspberry Pi OS to install all this sort of stuff on. And it makes it a hell of a lot easier when doing the coding and stuff like that, because you can be on a big PC and just copy it all in, troubleshoot it that way, rather than operating on a, using that thing. So, yeah, getting back to the media bridge, hopefully that will be an enterprise grade bridge, essentially, that I can send back to a custom server and have SRT out of there. That'll be pretty fantastic, and I will pop up a video and in guide instructions and show you how all of that works once I have that hot. Might be in another month or so. So anyway, thanks for watching. Do all the things with the buttons on the way down to the description so you can get all of the documentation and guide and all that sort of stuff, and I'll catch you in the next one.